Okay, so if you ever want to differentiate some sort of binomial, and it has to be a linear binomial to the power of n, then you can use this rule over here to differentiate. And in essence, this is actually the reverse of the chain rule. So a few things to note before we use this rule. First of all, what's inside the bracket here has to be of a linear nature. So the highest degree in here must be 1. So you can't have any quadratics here, cubics, you can't have trig, otherwise this rule would have to be changed a little bit. And over here, let's talk about where this actually comes from. So let's suppose you want to differentiate ax plus b to the power of n. Now if you want to do that, then what you end up with is, okay, let's just write it over here. So antiderivative of ax plus b to the power of n. Now, if you want to take the derivative of this, then by using the chain rule, you can say that you have n ax plus b to the power of n minus 1. Now, we made a substitution for ax plus b here, so we say that this is u or whatever substitution that you want to use. Now, of course, if you make the substitution, you have to multiply by du dx. So you have to multiply by what's in the derivative of what's inside your substitution, which is just a in this case. The b turns into 0. And what's happening in our rule over here is that instead of multiplying by what's inside the bracket, we're dividing by what's inside the bracket. So this is where this a here comes from at the bottom. Dividing by the derivative of what's inside the bracket. N plus 1 here, instead of multiplying by n, you want to be dividing by n, the index, but with an additional 1 because you're anti-differentiating. And of course, instead of n minus 1 here, you have n plus 1. And that's pretty much showing you how it's the reverse process of the chain rule, for a linear rule at least. Okay, so do a couple examples here. And of course, pause the video if you feel like you've got a good grasp on the rule, and you can attempt it yourself. Okay, so for this one down here, so first of all, plugging it into the rule. Now, imagine all this involves ax plus, so we have ax plus b to the power of n, and anti-diffing this would give you in the numerator the same thing, except the index is going to have an additional 1. So 6x plus 2 to the power of 5 now. And we get this from 4 plus 1. At the bottom, you just want to divide by a. A is 6. And n plus 1, and that's 5. Okay. And you can see that this one over here can be simplified to 6x. Actually, before we proceed, let's not forget our constant. Top can't be factorized any further. Well, I mean, you can take the 3 out of here if you really want to, but it's fine. I think we'll leave it for now. And it's going to be all over 30 plus c, since we are taking the indefinite integral of 6x plus 2 to the power of 4. Okay, for this one down here, now we're familiar with anti-differentiating this if we just had this bracket to the power of 5. But what do we do with this negative 3 over here? This one's a bit of a problem. So recall that if you ever have a constant multiplied by some sort of function inside an integral, you have to take this constant a over here to the outside and just deal with it later. So all you're really doing is you're anti-differentiating the hard part, and the constant can be left outside as long as they're multiplying by each other. So that's what we're going to do here. We're going to say that the negative 3 is outside. We're going to anti-differentiate 2x minus 7 to the power of 5 with respect to x. So we have negative 3 multiplied by 2x minus 7 to the power of 6, and at the bottom we need a down here, which is 2. That's just the coefficient of x, and it's multiplied by n plus 1. We know n plus 1 is 6 plus c. And just simplifying this a little bit, it's 3 over here can be crossed out with the 6, so we get 1 and 2. And this will give us, what would be, negative 1 on 2 times 2x minus 7 on 6. Oh, sorry, this one isn't 2, it's 4. Where's the eraser? Let's just go backwards here. This is 4. Okay. Now, using the previous 2 examples, you can probably try this one yourself. Otherwise, we'll go through this one as well. So, over here, this 3 in front, we don't want to deal with it when we want to anti-differentiate the bracket here. So, we're going to chuck this to the outside and anti-differentiate 7x plus 2 to the power of negative 2 with respect to x. And it doesn't matter if this n value here is positive or negative, we can still deal with it. So I'm going to get 3 multiplied by 7x plus 2, and we have negative 2 plus 1 over here, and that would be negative 1. Down at the bottom we have a, which is the coefficient of x, and we have n plus 1 again, so this is negative 1. Okay, and from here, you can see that this will be simplified down to negative 3 on 7 times 7x plus 2 to the power of negative 1. Of course, if you get rid of the integral sign, we do need to have our c term over here to say that you want to add some sort of constant since it's an indefinite integral. If you have a negative index here and you don't really want to deal with that, you can take that to the bottom, but it's not really the objective of this video here. And you can have your antiderivative in this form instead. It really depends on the context of the problem and what kind of form you actually want.